Hello, this is Tom Mack, Technical Support Specialist for Bacharach. Today I'm going to talk about troubleshooting flow faults in a multi-zone fixed gas monitor. Troubleshooting these faults is a straightforward process if you're methodical in your approach and you understand the product. Generally, a flow fault is a result of one or more issues: a system blockage, a mechanical problem, an electrical problem, or incorrect configuration. In this video, I'll explain how to recognize two types of flow faults, what steps you can take to pinpoint the problem, and how to return your system to normal operation. Large volumes of refrigerant can quickly displace the breathable air in a confined space and create a suffocation risk. Be sure to approach all alarms and faults with caution. The severity of these problems may be an unknown, so be sure to exercise appropriate caution when investigating faults and alarms, especially when entering a confined area that may be contaminated with large volumes of refrigerant. The multi-zone gas monitor alerts you if a fault exists. The yellow system fault light is one indicator. Other alert devices may include optional horns, strobes, and even integrated building management systems. In the case of a no-flow zone fault, the word no flow will appear next to each affected zone on the front panel display. The display will also show a fault code that indicates one or more no-flow zone faults. The fault code is a 4-position hexadecimal number that reflects the sum of all current fault codes. So a fault code of 0800 indicates one or more no-flow zone faults. A fault code greater than that indicates the presence of a no-flow zone fault and other active faults. For example, a fault code of 1800 indicates an 0800 fault and a 1000 fault. The 1000 fault is a no-flow on purge fault, indicating a blockage detected in the purge line. That's the line used to draw clean, fresh air into the system. No-flow zone and purge line faults are some of the most common faults that users may experience. They may appear individually or together. I'll show you how to troubleshoot both, but your MZ may only have one or the other. So your multi-zone gas monitor shows that you have one or more no-flow zone faults. This means the MZ is unable to draw a gas sample from those zones, which means those zones are not being monitored for gas leaks. Your next step is to diagnose the cause of the no-flow condition, so it can be corrected and proper monitoring can be restored. The following sections will step you through the diagnosis processes from simple to more complex. The multi-zone gas monitor takes up to 16 zone samples in a continuous round-robin fashion. Using the onboard pump, the MZ draws in a gas sample from the next sequential zone into the infrared bench, analyzes the sample, reports results, and then moves to the next zone. Depending on the sample line length, the number of zones, and how often you configure the system to re-zero, a complete cycle of all zones may take several minutes. So if you make changes to your MZ system in order to address a fault condition, give the system a few minutes to cycle through all zones before re-evaluating the current fault status. The previous fault will remain on the screen until the system cycles through all zones again and no fault conditions exist. The offending zone is resampled, the original fault condition is remedied, and the fault itself is cleared. So your first and easiest action in troubleshooting flow faults is to simply wait a few extra minutes to see if the fault condition clears, especially if you've recently made changes to your system. If the fault persists, you can then continue your investigation. Next are what I call phantom manifolds. This situation may not be the most common, but it is certainly easy to check. Depending on your application, MZs can be purchased with 1, 2, 3, or 4 manifolds, providing either 4, 8, 12, or 16 total zones to be monitored. If your MZ has fewer than 4 manifolds, the unused manifolds are disabled by default from the factory. However, if someone mistakenly enables those manifolds without an actual manifold being present, the MZ will report the corresponding zones as having no flow faults, a phantom manifold. Though this situation is highly unlikely, it is worth a quick check before tackling more complex troubleshooting steps. To check for a phantom manifold, use the Num Zones Installed setting in the System Setup menu to configure how many zones are installed in the MZ. Gas manifolds for the MZ are available in groups of 4 inlet ports each, so this setting can be 4, 8, 12, or 16, indicating 1, 2, 3, or 4 manifolds respectively. Compare the Num Zones Installed setting to the actual number of installed zones, 4, 8, 12, or 16. To do this visually, inspect the side of the MZ chassis and multiply the number of manifolds by 4. This number should match the number in the Num Zones Installed setting. If not, change it. Note that the number of installed zones may be more than the actual number of zones you plan to monitor. For example, an application requiring 10 zones to be monitored will require 3 manifolds or 12 installed zones. In other words, set the Num Zones Installed setting to the physical number of manifold zone inlets installed in your MZ, either 4, 8, 12, or 16. After making the change, be sure to wait for the MZ to cycle through all active zones again and verify that the no-flow zone faults have been cleared. If they have cleared, you had a phantom manifold, but you're all set now. If not, you need to continue your investigation. The next easiest flow fault to diagnose is to confirm that the pump is operating properly. A malfunctioning pump may create reduced or even no vacuum, which may result in a no-flow fault. Here's how to check if your pump is operating properly. From the diagnostic screen, check pressure, ambient, and vacuum readings. Properly operating pumps will show a pressure reading of approximately 1 psi below ambient, or about 13, and a vacuum reading approximately 3 psi below ambient, or about 11. If your system exhibits similar values, your pump is working properly and is not the cause of your no-flow fault. So you need to troubleshoot further for clogs, restrictions, electrical problems, or mechanical problems. If your pressure and vacuum values are not at the typical and optimal readings of 13 and 11, your pump is suspect, but you still need to confirm. At this point, the no-flow condition is likely either a faulty pump or possibly